In today's video, we're going to learn how to write compound inequalities. You'll remember from our last video that we learned how to solve compound inequalities, and then we took the compound inequality, either an AND compound inequality or an OR compound inequality, and we typed it into the answer blank. In this video, if you look at example 1, we're given a number line with solution sets graphed in red, and we're going to create a compound inequality based on the solution set, or the values that are included in the solution. So if I look at the first example, I see that the solution set is a connected line. And since it's a connected line, I know that it is a AND compound inequality. And if it's an AND compound inequality, I know that I'm going to have x, or the values that are part of the solution, in the middle, with my smallest value on the left and my largest value on the right, and a symbol in between my smallest value in x and a symbol in between my largest value in x. And since I know that my smallest value, or I know that x is going to be larger than my smallest value, I can say that x is greater than my smallest value. And since I know that x is going to be smaller than my largest value, I can say that x is less than my largest value. Okay, now I'm going to try to figure out what values I can substitute for my smallest value and what values I can substitute for my largest value. So I'm going to look at my endpoints for this, and it looks as though this value right here is my smallest value, and this value right here is my largest value, and all these values in the middle are a part of the solution set. So the smallest value in this compound inequality looks like is -7, since -7 is between -6 and -8. So I'm going to go ahead and write -7 is less than x. If I read this from right to left, x is greater than -7, which we already knew that because we knew that x would be greater than our smallest value. Now if I look at my largest value, and it seems like my largest value is 6, I can say that x is less than 6. And I'm almost done here. All I have to figure out now is whether or not those endpoints, or those values on the end, my smallest and largest, are included. So I'm going to come over here on -7 and look at the dot. Since the dot on -7 is open, that means -7 is not a part of our solution set. So I'm not going to write an equal to here. I'm just going to leave it as -7 is less than x. If I look at my second endpoint here, 6, since the dot on 6 is closed, that means 6 is included in the solution. So 6 can also be, or x can also be, equal to 6. So we're going to make this one an equal to. And now I'm going to type this in just as it is. -7 is less than x, which is less than or equal to 6. Alright guys, example number 2. Here you'll see right away that the line, or the red line of the solution set, is different than it was in example 1, meaning that the line is not connected, it's actually disconnected. If the line is disconnected, then you know right away that it's an OR compound. And just like yesterday when we were solving for OR compounds, what we had was we had one inequality with OR connecting our second inequality. And when I write these inequalities, I'm going to write x first because that's the way we're going to type it into the computer. So I know that x, some symbol, some value, and x, some symbol, some value. Right? So let's focus on the first section, or the first part of the red line here. Right? And we know that the endpoint is -12, so we know that this value is -12. And now we've got to figure out, is x greater than -12, or is x less than -12? Well, since the red line is covering values that are less than -12, then we can say that x is less than -12. And the final thing that I have to figure out with this first part is whether or not -12, or the endpoint, is included. So I look at the dot on negative 12 and it's closed. Since it's closed, it's an equal to, meaning that x can be negative 12 itself. So I'm going to make this an equal to. Now I'm going to look at the second part of this line, and it looks like the endpoint here is 4. Now are values that are greater than 4 part of this solution set? Well, it looks like they are, because the red line covers values that are greater than 4. So I know that x has to be greater than 4. And now I'm going to look to see if the endpoint, or 4 itself, is included. Since it's an open circle, it is not included, so it is not an equal to, so we're just going to leave it as x is greater than 4. And now I'm going to type this in exactly as it appears in front of me. X is less than or equal to negative 12, and I'm going to space, type or, space, and then I'm going to type the second inequality. X is greater than, sorry, that's a capital X. X is greater than 4. Alright, example number 3. Since you guys have seen 2 examples and I've explained them both in detail, we're going to fly through these a little bit quicker now. We notice right away that in example 3 that the line is connected, so we know that this is an AND. So we know that we have x, our lowest or smallest value, and our greatest value. Our smallest value here appears to be negative 9. And we know that x is going to be greater than our smallest value. And our largest value here is 2. And we know that x is going to be smaller than our greatest value, which is 2. Okay? Now we've got to figure out whether or not the values are included, or the endpoints are included. Since there's an open circle on negative 9, negative 9 is not included, so we're going to leave this just as it is. And the endpoint 2, or the largest value 2, is included because the circle is closed, so we're going to make this an equal to. And now we're just going to type this in as it is. So I have negative 9 is less than x, which is less than or equal to 2. Example number 4. Okay, right away you'll notice that this is a disconnected line, so we know this is an OR. So we know that we have one inequality here with our value connected by OR, and our second inequality with our value. So the endpoint of our first inequality looks like is negative 6. So I'm going to go ahead and write in negative 6 right here. And values that are less than negative 6 are part of this solution set. So x is less than negative 6. And is negative 6 included? So we're going to look to see it's a closed circle, so it is included. So we're going to make this an equal to. And then we're going to look on the second part of this solution set, and it looks like our endpoint here is negative 1, since negative 1 is between 0 and negative 2. So I'm going to write negative 1, and values that are, the red line is covering values that are larger than negative 1. So I know that x is greater than negative 1, and the circle on negative 1 is open, so I know that negative 1 is not included, so I'm just going to leave it as greater than. Now I'm going to come over here to our answer blank and type in the inequality. X is less than or equal to negative 6, space, or, space, x is greater than negative 1. Example number 5. Okay, so here we have an AND, since the line is connected. So we know that we have our smallest value, x, and our largest value. We know that x is going to be greater than our smallest value, and we know that x is going to be less than or smaller than our largest value. Our smallest value here looks like it is negative 6, and the circle on, or the dot on negative 6 is closed, so negative 6 is a part of the solution, so it's an equal to. And our largest value, or second endpoint, is 7. And the dot on 7 is open, so we're just going to leave it as a less than. Now we're going to type it in just as it appears. Negative 6 is less than or equal to x, which is less than 7. Example number 8. Oh, sorry, example number 6. So here we have an OR, since the line is not connected. And our first inequality, we've got x is, and it looks like the endpoint here is negative 2. And since the red line is values that are smaller than negative 2, we know that x is less than negative 2. And the endpoint is there's an open circle on negative 2, so negative 2 is not included, so we're going to leave that one as is. Or x is, and it looks like our endpoint here is 4. And since the red line is covering values that are greater than 4, we know that x is greater than 4. And the circle on 4 is closed, so that means 4 is included, so x is an equal to as well. Now we're going to type in our answer. X is less than negative 2, space, or, space, x is greater than or equal to 4. Alright, example number 7. Here the line is connected, so we know that this is an and we know that x is going to be smaller than or larger than our smallest value and smaller than our largest value. And the smallest value here is negative 4, and the largest value here is 2. Now I'm going to look at my smallest value, negative 4. Since it's an open circle, I'm just going to leave this as a negative 4 is less than x. And our largest value, 2, also has an open circle, so I'm going to leave this as x is less than 2. And now I'm just going to type in what we created. So negative 4 is less than x, which is less than 2. Example number 8. Here is a disconnected line, so we know that we have an OR. And our first inequality, our endpoint is 5. And the red line is covering values that are less than 5, so we know that x is less than 5. And the circle on 5 is closed, so we know that 5 is included, so we're going to write equal to. Now our second inequality over here, we have x, and our endpoint is 10. And the red line is covering values that are greater than 10, so we know that x is greater than 10. And the circle on 10 is open, so we're just going to leave this as a greater than. Now I'm going to come up here to type in our answer. X is less than or equal to 5, space, or x can be greater than 10. Alright, example number 9. Here we have an AND, since the line is connected. And it looks as though our smallest value here is negative 5, and our largest value is 1. And since the circles or the dots on both of our endpoints, our largest and our smallest value, are closed, we know that these are both equal to's. Negative 5 is less than or equal to x, which is less than or equal to 1. Last example. Here we have a disconnected line, even though it looks like it's connected, so we know that it's an OR. And we know that x is negative 6, and x is, and that value is what? Negative 5. Okay? So if we look at our first inequality, we see that the values that are less than negative 6 are included since they're red. So we know that x is less than negative 6. And the circle on negative 6 is closed, so we know that this is an equal to. And if we look at our second inequality, values that are greater than negative 5 are included on the red line. So we know that x is greater than negative 5, and the circle on negative 5 is closed, so we know that this is a equal to. I'm going to type this in real quick. X is less than or equal to negative 6, space, or, space, x is greater than or equal to negative 5. Again, the biggest things in this lesson are inputting it into the computer. Make sure to include no spaces with and, can't even read that, and space between or.